All right, good day everyone. My name is Kadek Pramana Jaya. Today I would like to present a mathematical topic entitled quadratic function. In this presentation, I will explain what a quadratic function, its general form, characteristic of its graph, and the discriminant value and an example problem. So let's begin. Before we discussing the graph, we need to understand the meaning of a quadratic function. A quadratic function is a function whose highest power of the variable is 2. Quadratic functions are very important in mathematics because they can be used to model many real-life situations such as projectile motion, optimization problems, and economic analysis. The graph of quadratic function is called a parabola. The main question is how can we determine the characteristic of parabola. To answer this question, we need to understand the general form of quadratic function first. Next, the standard form of a quadratic function is f of x equals ix squared plus bx plus c. Quadratic function can also be written as y equals ax squared plus bx plus c. In this form, a is the coefficient of x squared, where a is not equal to 0. B is the coefficient of x, and C is the constant term. The value of A is very important because it uh, determines the shape and the direction of the parabola. If A equals 0, the function is no longer quadratic. Therefore, A must always be different from 0. The shape of parabola depends on the value of coefficient a. If a is greater than 0, the parabola opens upward. This means the graph has a minimum point. On the other hand, if a is less than 0, the parabola opens downward. In this case, the graph has a maximum point. Therefore, by looking at the sign of a, we can immediately determine the direction of a parabola. Another important characteristic of quadratic function is the y-intercept. The y-intercept is the point where the graph crosses the y-axis. In the quadratic function, fx equals x squared plus bx plus c, the y-intercept is always equals to the constant term c. Therefore, the coordinate of the y-intercept is 0, comma c. For example, if c equals 10, then the graph intersects the y-axis at the point 0, comma 10. The highest or lowest point of a parabola is called the vertex or extremum point. To find the x-coordinate of the vertex, we use the formula x sub p equals negative b over 2y. After finding x sub p, we substitute into the function to obtain y sub p. Next, y sub p equals f of x sub p. The vertex is important because it tells us the maximum or minimum value of the quadratic function. All right, next we have the discriminant value. The discriminant helps us determine the number of real roots of a quadratic equation. The formula is d equals b squared minus 4ic. There are three possible cases. First, if d is greater than 0, the equation has two distinct real roots. Second, if d equals 0, the equation has exactly one real root. Third, if d is less than 0, the equation has no real roots. The discriminant also helps us understand how the graph intersect the y-axis. Next, there's one method to find the roots of a quadratic equation is the factoring method. If the quadratic function can be factored, we write it as x plus p times x plus q equals 0. The value of p and q must satisfy two conditions. The sum of p and q must equal to the coefficient of x. The product of p and q must equal the constant term. After factoring, we set each factor equal to 0 and solve for x. Now let's solve an example. Given the function f of x equal x squared plus 7x plus 10, from the standard form we identify a equals 1, b equals 7, and c equals 10. Since a is positive, the parabola opens upward. Next, we can calculate the discriminant, right? D equals b squared minus 4ac. D equals 7 squared minus 4 times 1 times 10. D equals 49 minus 40, and D equals 9. Since D is greater than 0, the equation has two distinct real roots. Next. Now we factor the function x squared plus 7x plus 10 can be written as x plus 5 in parentheses times x plus 2 in parentheses. Therefore, x plus 5 equals 0, giving x equal negative 5, and x plus 2 equals 0, giving x equal negative 2. Therefore, the x-intercept are negative 5 and negative 2. The graph intersects the x-axis at two different points. Next. All right, to conclude my presentation, a quadratic function has the general form of f of x equal ix squared plus bx plus c. The coefficient a determines whether the parabola opens upward or downward. The constant c determines the y-intercept. The vertex represent the maximum or minimum point of the graph. The discriminant helps determine the number of real roots. Finally, the roots can be found using methods such as a factoring. So thank you very much for your attention and goodbye.